All right. Good morning. Welcome back. Let's look at the schedule really quick. Today is September 23rd. We're going to move on to section 2.3, and we're going to play around with matrices again today. You are still working on that used car project, or maybe some of you are done. I haven't even checked your shared folder yet to see if they're done. But notice we don't even have class on Friday this week. First of all, you are all encouraged to go to Dr. Lefebvre's inauguration ceremony. But we will not have class, but I just entered this in here. Your used car project should be done by the end of this week, okay? Because I'll go in probably Monday and, well, maybe on the weekend. I don't know if I'm going to work this weekend or not, but I'll go in and start looking at them. So be sure that you have what you need there. And if you have questions about that between now and then, about that project, just ask me. But you guys know where the scoring rubric is. You can see exactly how I'm going to give you that score, right? So if you just follow the instructions and whatnot on that sheet and you know what you're doing, you should be pretty good to go. Okay. Section 2.3 is called matrix operations. So we're going to use matrices for a few things in here. Number one, we already determined that they can be extremely useful up in section 2.1 and 2.2 for solving systems of equations, 2 by 2, 3 by 3. We didn't do a 4 by 4, but we could do it, right? So we can solve systems of equations where we just set up what they call an augmented matrix, and we leave out all the x's and the y's and the z's and the equal sign, and we just do all the coefficients, right? And we know how to do that on our computer by going to reduced row echelon form, and it spits out the answer in a matter of no time. And we learned last time that that is a breath of fresh air compared to doing it by hand, right? So we're going to do some of the same stuff today. I'm going to show you a little bit about where a matrix can be useful, and we'll talk a little bit about how you would do it by hand, but then again, we're going to use our computers to kind of do the heavy lifting for us. So the first thing it talks about in section 2.3 is actually super, super easy. We're just going to talk about it a little bit, and then we're going to move on to a little bit more complicated stuff. If you look at your section 2.3, matrix operations, it talks about finding the sum and the difference of two matrices. And it goes through and it says describing matrices. What does this mean? We know, just by way of terminology really quick so we get our vocabulary correct, a matrix is determined by the number of rows that it has and the number of columns that it has. So the one that I'm pointing at right now would be called a 3 by 3 because it has 3 rows and it has 3 columns. Okay? We always do rows by columns. Rows come first, columns come second. This would be a 2 row by 2 column. So 2 by 2, 3 by 3. This one is a 3 by 2. 3 rows, 2 columns. Right? So we always go rows by columns. So example 1. What are the dimensions of matrix A? That is a 3 by 2, right? And then it says, what are the entries in, it says 3, 1, and 2, 2. Well, that would be row 3, column 1. Row 2, column 2. This is just a little bit of terminology you can read on your own. It's not super important. I'm not so much worried about the labels and stuff like that. I just want you to have a conceptual understanding that we go rows by columns, okay? So super, super easy. It says, what happens if we wanted to add 2 matrices together? So example 2 is matrix A and matrix B. Notice we can only add them and subtract them if they're the same dimensions. This is a 3 by 3, this is a 3 by 3. It says find the sum of the two. What do you think you're going to do? Match up the corresponding entries and add them together, right? So in row 1, column 1, we have a 2. Over here in row 1, column 1, we have a 6. What are we going to do? Add them together and we get 8. Right there. So you just match up the corresponding parts and you add them together. I'm not even going to practice that because I know you guys can handle that. So what happens if we're subtracting them? Same thing. Find the corresponding one. So, you know, the 12 and the negative 12 go together. This 2 and this negative 2 go together, and you would subtract them. So that does like how to add them, how to subtract them. You can also do what's called a scalar multiplier. Like let's say in example 3, you have this 2 by 2 matrix and you want to multiply it by 3. What are you going to do? Every single guy gets multiplied by 3. It's like the distributive process, right? So this would be a 24 and a 3 and a 15 and a 12. Okay, again, super easy. I'm not even going to practice those in class. And we're not going to do a lot of applications of that per se. That's just really, really common sense. What we are going to do is we're going to look at what we call finding the product of two matrices. Taking a matrix times a matrix. And there's a process for this, and it's a little cumbersome, and it's kind of like, what? Why are we doing it this way? And it can get a little confusing. So we're going to go over an example, hopefully that makes conceptual sense on how that works. And then we'll practice a few of them together. So notice I'm on page 95 here of your textbook. It says we can multiply two matrices together. It says, the last sentence says, if the inner dimensions do not match, then the product is not defined, meaning we can't do it. So if I have a matrix and it's a 2 by 3, remember this is the number of rows. It's always rows by columns. Rows go first, columns go second. So this guy has 2 rows and it has 3 columns. This guy has 3 rows and 3 columns. Whenever we do matrix multiplication, the number of columns in the first guy has to match the number of rows in the second guy. If it doesn't, you can't multiply them. The product is just not defined. Okay, so I'll show you an example of that. Before we get into the actual process and how we multiply them, I'm going to jump to a different example. But look at matrix A and matrix B. Okay, quick. This is a what by what? 2 by 3. And this is a 3 by 3. So if I write that up here, if I say I got a 2 by 3, and I'm going to multiply it by a 3 by 3, do the inner dimensions match? Does the number of columns in the first guy match the number of rows in the second guy? Yes, it does, because this 3 matches this 3. So I'm good to go there. Okay, that tells me that I can multiply them. If the answer to this was no, you can't multiply them. Okay? The second part that is nice here is when I do multiply these, my product is always going to be what the outside dimensions give me. So my answer when I'm all done is going to be a 2 by 3. See that? Okay, so they go through and they're just using A's and B's. They're just doing this very abstractly in this example, and I'm not going to go through that one. Let's look at this. It says, note that matrix multiplication is associative. So if I take A times B and then take it times C, that's the same as taking B times C and then taking it times A. It's also distributive. Here's the one I want to talk about, though. It is not commutative. We learned a long time ago that 2 times 3 is the same as 3 times 2, right? When I multiply 2 numbers, does it matter which one I put first? No. 10 times 12 is the same as 12 times 10. You guys learned that in elementary school, right? Okay. When we multiply 2 matrices together, that is not the case. It is not commutative. So if I have matrix 1 times matrix 2, that is not the same as matrix 2 times matrix 1. Okay? That might be a difficult thing to gather in your brain right now, but you'll see why. Let me show you this. Let's say this guy was matrix 1 and this guy was matrix 2. And we already determined that we could multiply them, correct? What happens if I flip it around? And my first guy was the 3 by 3, put that one over here, and I was going to multiply that one times the 2 by 3. You see the problem? I can't multiply them. They don't even match up anymore. So that's one example showing that it is not commutative. One of them I can do and I'm going to get an answer. The other one isn't even defined. And all I did is I took them and I went like this. Okay? So do you believe me now that it is not commutative? Even if it was the same. Even if I had, say, a 3 by 3 times a 3 by 3. Can I do it? Yes. What's my answer going to be? A 3 by 3. Even if I switched them, could I still do it? Yes, but I'm going to get a different answer. All right? So again, not commutative. Okay, I'm going to jump to more of a, before we do these examples with just computation, I'm going to go down to this example 7, because this one actually has labels, so it's not so darn abstract. It gives you a scenario where a couple of soccer teams are trying to buy equipment. Okay, it says we have a table representing the following. Example 7. It says we have two soccer teams, the Wildcats and the Mudcats. Each of them needs to buy some equipment. They each need goals, balls, and jerseys. But notice they need different numbers. Like the Wildcats need 6 goals, but the Mudcats need 10 for some reason. And the Wildcats need 30 soccer balls, but the Mudcats only need 24, and so forth. Okay? When they go to the store, they find out that goals cost $300, balls cost $10, and jerseys cost $30. So the idea here is to figure out what's the total bill going to be for the Wildcats, and what's the total bill going to be for the Mudcats if they go shopping at the store. Now, even if you know nothing about matrices, I bet you guys could figure that out. Yes? Think about what you would have to multiply and add together in order to make this happen. Let's say you're the manager of the Wildcats. You go to Shields. What's your total bill going to be? But before you even tell me what your total bill is going to be, how are you going to calculate your total bill? Anybody want to yell it out? But even if we don't use a matrix yet, let's pretend we don't even know what a matrix is, just conceptually.
Cost times however many.
Yeah. So what am I going to take? What times what?
300 times.
300 times 6. Do you guys agree? Because it's $300 times 6 goals. So it's going to be 300 times 6, which is 1,800. So I'm going to go 300 times 6, and that's going to give me 1,800. Okay, what else do I need to do? 30 times 10, or since I'm going with the price first, I'm going to do 10 times 30. That's 300, right? And this is going to be 30 times 14. And that's going to give me, what, 420? And then what am I going to do? I'm going to add them all together, and I'm going to get 2520. That's how much it's going to cost the Wildcats to get their stuff. Okay? Could I do the same thing for the Mudcats? Sure I could. Okay, so notice what we did. We ended up taking the 300 times the 6, the 10 times the 30, and the 30 times the 14. Okay, now let's talk as though we were doing this as a matrix. Okay? What kind of matrix is this guy? Dimensions. It's a 3 by 2. Do you guys agree? This is a 3 by 2. What about this guy? It's a 3 by 1. Okay? So can I take, if I call this matrix 1, and I call this matrix 2, can I take, so this is matrix 1, matrix 2 is a 3 by 1. Can I multiply those two together? No, not in the way that they are set up right now. It's not defined because this does not work.
Can't you make 2 3 by 2s?
What do you mean?
Never mind.
There is going to be a way we're going to be able to pull this off. And you might even see, if you look at the bottom of the page, what did they do here? They left the Wildcats and Mudcats as a 3 by 2. Do you see how they did this? 6, 10, 30, 24, 14, and 20. What did they do with the prices? Instead of making it a 3 by 1, they wrote it horizontally, and they made it a 1 by 3. Okay, so let me do that really quick. Let's change this to a 1 by 3. Instead of writing it down, I'll write it across. Does that make my life better? Yeah, it doesn't work. I don't want to take M1 times M2. What do I need to do? M2 times M1. I need the M2 out front. So if I do 1 by 3 times 3 by 2, does that work? Yes. Okay, so again, this is all about organization, right? So here's what we're going to do. Let's go through. I'm going to pull this up here. Let's write this down. I'm going to show you on a piece of paper how we're going to do this. So I'm going to write it as 300, 10, and 30. So I'm going to write the first guy as a 1 by 3. And then the second guy, I'm going to write the same way that they have it, as a 3 by 2. So 60, 30, 14, 10, 24, and 20. Now I'm going to go to my sheet here. Okay. So we are going to, this is a 1 by 3. This is a 1 by 3. And this is a 3 by 2. So again, are we going to be able to multiply them? Yes. I double check my inner dimensions to make sure that I can even do this, right? My final answer is going to be in what shape? 1 by 2. My final answer is going to have one row, and 2 columns. I'll just put like a blank and a blank there. Okay? So here we go. I'm going to put up the labels again just so we can see it. I think the first one was the Wildcats and the Mudcats. So this was the Wildcats. This was the Mudcats. And then it went goals, balls, jerseys. So goals, balls, jerseys. Right? And then for the pricing, it was goal, ball, jersey. Goal, ball, jersey. Are we okay with that? Okay. So the way that matrix multiplication works is you take your first matrix, you take row 1 times column 1, and then row 2 times column 1, row 3 times, and so forth. And then you go to row 1 times column 2, and so forth, right? So that's why the 3 and the 3 have to match. So notice my row 1 is this guy here. I'm going to take row 1 times column 1. So think about what we're doing when we do that. I'm going to do each one multiplied, and then I'm going to add the individual guys together. So remember back when before we even talked about what a matrix was, we said we were going to take 300 times 6. So what is that? It's the price of a goal times the number of goals that the Wildcats need. We're going to take 300 times 6, and we're going to get 1,800. So it's 1,800 plus, now we're going to take, what? 10 times 30, the price of a ball times the number of balls, and we're going to get 300 plus the price of a jersey times the number of jerseys, which is 420. And all of those added together are going to be the first entry in my product matrix, my answer. Okay? And we said that was going to be, if I add it all together, I get 2520. Okay? So I've done row 1 times column 1. Okay? Now if I had a second row, which I don't, I could do that one times column 1. And if I had a third row, that one times column 1, and so forth. But I'm done. I'm done with all my rows. So now I'm going to go to the next column. Now I'm going to do row 1 times column 2. So again, I'm going to take the 300 times the 10. That gives me 3,000. The 10 times the 24 gives me 240. and the 30 times the 20 gives me 600. Okay, what is that? That is the price of a goal times the number of goals the Mudcats need, the price of a ball times the number of balls the Mudcats need, and the price of a jersey times the number of jerseys the Mudcats need. And it's 3,000 plus 840, which gives me 3,840. So my final answer, if this was a 1 by 3 and this was a 3 by 2, my final answer we said was going to be a 1 by 2, right? A 1 by 2. My final answer is 2520, 3840. And then, of course, we have to understand, what do those numbers even mean? It's the total price for the Wildcats and the total price for the Mudcats, right? Okay. So this was a relatively simple example in the sense that we only had 2 teams and they were only buying 3 pieces of equipment. So did the matrix help us a ton here? You guys were able to solve it pretty fast without the matrix, yes? Okay. Now I want you to imagine that there are, this is, I don't know, the Fargo Park District, and there are 97 soccer teams, and all 97 soccer teams need 12 different pieces of equipment. That would be a massive matrix, right? So if you could set that matrix up one time and put it into a big darn spreadsheet, do you see how the computation by using technology and using the matrix would be 1,000,000 times better than trying to work all of that out by hand? Not only that, what happens if somebody changes the price? What happens if a goal goes on sale? Instead of $300, it goes on sale for $250. You're going to want to go through and do all those computations again? Or can you go to your computer or your spreadsheet and just change the 300 to 250 and everything just changes automatically in real time, right? That's the power of the matrix. Maybe a little bit difficult to understand how to set it up and how to put it together and what your answer means, but once you get the conceptual understanding of what it is, super useful, very useful and powerful. Okay, so let's try an example. What did I say we were going to try here? Try it now on page 98. Let's try that one. I'm going to scroll up to this one. Okay, let's try this guy right here. Let's multiply. There's no labels. There's nothing going on here. This is just an abstract whatever, right? We want to take the first matrix times the second matrix. First of all, can we do it? Yeah, because the first guy is a 3 by 2 and the second guy is a 2 by 2. So we're good to go there, right? And my resulting matrix, my final answer is going to be a what? A 3 by 2. So I'm going to write this on paper again here. 1, negative 2, 4, 0, negative 1, 3, 2, 3, and 1, negative 1. Okay, here we go. We want to take this times this. Okay, we want to take row 1 of the first guy times column 1 of the second guy. All right, so, and then we're going to add all these together, but we can do this in our head. Row 1 times column 1 is going to be this guy times this guy, and this guy times this guy. See that? See how we match it up? So 1 times 2 is 2, and negative 2 times positive 1 is negative 2. So I got a 2 and a negative 2 for a total of 0. See how we got that? 2 and a negative 2 for a total of 0. And just as a reminder to myself, I told myself this was a 3 by 2 and this was a 2 by 2. And that tells me that yes, I can do it. And that tells me that I'm going to get a 3 by 2 as my final guy. So I'm going to write this out so I can already see my There's going to be 3 going down and 2 going across is going to be my final answer, right? So I did row 1 times column 1, and I got my upper left. Now I'm going to move down. Let's go to row 2. So I'm going to fill in this number right here, but I'm going to do row 2 times column 1. Then I'm going to do row 3 times column 1. Then I'll be done with my rows, or my first column. Then I'll go over and then I'll do that second column, okay? So this entry right here is going to be row 2 times column 1. So 4 and 2 give me 8. 0 and 1 give me 0 for a total of 8. Anybody confused yet? If you're anything like me, you need to practice this like multiple times to keep your brain straight. Is anybody struggling with keeping your brain straight right now? Yeah, I think it's tough. So you got to just get used to it, and you got to practice a little bit. What am I going to multiply to get my bottom guy? Row 3 times column 1. Okay, so negative 1 and 2 gives me negative 2. 3 and 1 gives me 3, and if I add a negative 2 and a 3, I get positive 1. Now I can go back and I'll start over with row 1, and now I'll go to my second column. So 1 and 3 give me 3, negative 2 and negative 1 give me 2, 3 and 2 is 5. Now I'll go down to row 2, column 2. 4 and 3 is 12, 0 and negative 1 is 0, 12. And finally, row 3, column 2, negative 1 and 3 is negative 3, 3 and negative 1 is negative 3 for a total of negative 6. So this is very abstract, okay? It's abstract in the sense that we have no idea what this matrix is. It's just a mess of numbers. We have no idea what this matrix is, and when we multiply it together, we have no idea what we just calculated. So from an abstract standpoint, we don't even know what we just did. We just went through some mathematical procedure that is defined as multiplying 2 matrices together. That's all we did. I hope from the soccer example, you can see why we did it, right? Like it makes sense. Why would I multiply the 300 times a 6 and get 1,800? Because that's the price of a goal times the number of goals that they need, so it's going to be $1,800. To me, that makes sense. To me, this is a yawner. This is like, what did I just waste my time for, right? So it's the application of the matrices that is going to become more important. So let's look at the answer. The answer to that guy was supposed to be here it is right here. 0, 5, 8, 12, 1, negative 6. 0, 5, 8, 12, 1, negative 6. That's what we got, right? The answer at the bottom of the book there. Okay, let's try one that has a little bit more meaning again. You know, more of an application problem. But before we do that, let's see if we can do this on our computer. Open up your GeoGebra. Because again, we don't necessarily want to go through the by hand process. We want to be able to use our calculator to help us, right? So I'm going to go to View again, and I'm going to open my spreadsheet. Okay. And let's do the one that we just did. So I'm going to type in 1, negative 2, and 4, 0, and negative 1, and 3. And then down here somewhere I'm going to do a 2 and a 3, and a 1 and a negative 1. It doesn't matter where you put it on the spreadsheet. You can put it anywhere, because all we're using the spreadsheet for is being able to copy and paste it into a matrix. That's all we're using it for, right? So I'm going to take this guy. Do you have your GeoGebra open, Matt? You want to practice this? I'm going to change this guy into a matrix, create matrix. Notice it gives me something called M1. That was my first guy. And over here I'm going to go create matrix, and that's going to give me M2. Now remember, it's important that we do this in the right order, because we said that matrix multiplication is not commutative, right? So which guy is the first guy and which guy is the second guy? We did M1 times M2. Do you guys agree? So down in your input bar, M1 times M2, and it'll spit it out, and sure enough, that's what we got when we did it by hand. Now for the fun of it, try M2 times M1. Try flipping them around and see what your computer tells you. Undefined. Your computer is telling you, hey, your inner dimensions don't match. The columns in the first one do not match the rows in the second one, therefore they are not multipliable. It doesn't have any meaning in that sense. What do we think? Not too bad? Okay, let's try something a little more fun. Go to your Blackboard. And if you go to Course Docs and Links, and scroll all the way to the bottom, underneath section 2.3, I gave you a vegetable market. Do you see that? It's a spreadsheet, Excel. Now, Excel can do matrix multiplication as well. Honestly, I haven't done it for a while, so I'm not even sure. So I'm just going to continue to use my GeoGebra to do it. But there's a way to do it on Excel as well. I should have figured that out for today's class, but I didn't. Okay. Everybody got this open? Okay, so we got a farmer, or a gardener. This guy has two gardens, garden 1 and garden 2. In each garden, he has cucumbers, tomatoes, and potatoes. And these are measured in kilograms, so he already did his harvest. So from garden 1, he got 30 kilograms of cucumbers, 20 kilograms of tomatoes, and 50 kilograms of potatoes. From garden 2, he got 70, 80, and 50. Okay? He's got two different places where he could potentially sell his produce. That's market number 1 and market number 2. Two different competing markets. Market number 1 will pay $10 per kilogram for cumbers. I think that should say cucumbers. Sorry about that. Okay? They will pay $20 a kilogram for tomatoes, and they will pay $30 a kilogram for potatoes. Tomatoes and potatoes. But then market 2 will pay 20, 30, and 30. So, we got two different gardens. We got two different markets. Right? There's kind of a lot going on here. The question is, which market should he choose to do business with for each of his gardens? Like, should he take garden 1 to market 1, or should he take it garden 1 to market 2? Or should he take garden 2 to market 1, or should he take garden 2 to market 2? Or let's say he was only going to do business with one market. Which market should he go to? There's a lot of different ways we could phrase this, right? So what we want to do, again, pretend that you don't even understand matrices. If you were just looking at garden 1 and cucumbers, how would you determine the price that you would get from the two markets? What would you do? Multiply. I'd take my 30 kilograms of cucumbers, and I'd say market 1's going to pay me $10 per kilogram. 10 times 30 is 300. Market 2 is going to pay me 600, right? Well, what happens if I went all the way through and I took row 1 times column 1? The 30 times the 10, the 20 times the 20, and the 50 times the 30. That would give me some grand total. But what would that grand total be? What would the label on it be? It'd be dollars at market 1. So if I took all of my garden 1 over to market 1, that would be the total number of dollars for garden 1 at market 1. I could also do the total number of dollars for garden 1 at market 2. Total number of dollars for garden 2 at market 1, total number, right? Okay, so let's do this. Go ahead and grab all of this, and I'm going to copy it. And then I'm going to go to my GeoGebra. I'm going to erase this. And I'm just going to go up here and I'm going to paste it. Control V. There it is. I'm going to make that a lot bigger. I'm going to make, look. I'm going to make this a little wider so I can see what's going on. You guys can do whatever you want with your screen. I like to have the labels there, because if the labels aren't there, it's easy for me to forget what the heck I'm doing. But if I can see the labels, I can kind of turn my abstract brain off and just look at the common sense of what's going on. Without the labels, it's hard, I think. Okay? So, do you guys agree that if I made my first guy into a matrix, he'd be a 3 by 2? And that this guy here, 2 by 3? 2 by 3, and this guy over here is 3 by 2. 2 by 3, 3 by 2. Can I do it? Yes. Okay, so let's make this guy into a matrix. I'm just going to grab the numbers now. Just the numbers. Create matrix. There's a matrix. And let's take this guy and create a matrix with him. And now I have matrix 1 and matrix 2. It's a 2 by 3 times a 3 by 2, so I can do it. And my resulting matrix is going to be a 2 by 2. Now, before we even multiply them, think about what those numbers are going to be in your 2 by 2. We're going to get a 2 by 2 when we're all said and done, right? I want you to understand what the numbers are going to be before you actually compute it. We have a 2 by 3 times a 3 by 2. So yes, we can do it. And my result is going to be a 2 by 2 result. So I'm going to have 4 total numbers, 2 by 2. The number that I get in the upper left corner, what's that going to be? It's going to be a number, obviously, but what's it going to represent? Which garden and which market? Garden number 1, market number 1. Correct? If I take garden number 1 to market number 1, I'm going to get that many dollars. What's this guy going to represent over here? Garden 1, market 2. And this guy? Garden 2, market 1, and garden 2, market 2. All right? Should we give it a run? Now we could do it by hand, but let's do M1 times M2. Enter. Okay, there's my numbers. 2200, 2700, 3800, 5300. So, if I was willing to split up my gardens, where would I want to take garden 1? Which market should I take it to? Obviously, I should take it to market 2, because garden 1's only going to pay me 2200. Market 1 is going to pay me 2200. Market 2 is going to pay me 2700. I'm going to make $500 extra if I go to market 2. How about garden 2? Which market should I go to? Obviously, market 2 is going to pay me more again. What happens if I wanted to get the sum total? If I only went to market 1 or if I only went to market 2? I could just add these two together, right? The sum of these would be my market 1 and the sum of these would be my market 2. Obviously, market 2 looks like the better way to go any way we slice it, right? Market 2 is paying more money per stuff, right? But now here's the beauty of the matrix. And do you guys have it, basically what I have right now? Now what you can do is, let's say the guy who's running market number 1 says, oh man, market number 2 is giving a better price. I need to up my game. Instead of paying $10 for cucumbers, I'm going to beat their price. I'm going to pay 21. So I'm going to change that 10 to a 21. And you see how everything just changes all at once? Market 1, I just gave $21 to. And now he's like, hey, they're beating me in tomatoes as well. So I'm going to beat them. I'm going to make that a 31. And now what happened? See how everything changed? When I change my spreadsheet, it changes this, and it changes this, and it changes the product, it changes everything. And I can tinker around with the prices, and everything changes in real time. I don't have to retype everything in again. Right? How do we feel about that? Anybody confused? There's a lot going on, right? So go ahead and just play with it a little bit. Maybe Market 2 says, oh, hey, I'm going to go to $22. Now look how close they are. Now they're within $10 of each other. Oh, but I'm only going to give $28 for this guy. But then I'm going to go $30.50 for this guy or something like that. And we can start changing numbers as long as we understand what this is. Maybe put labels on it. We can massage it and do all kinds of stuff. Maybe he found out that he didn't have 30. Maybe he found out he had 32 kilograms. So I can change that number. And I can just start tinkering and playing with it. So that is like the practical application of being able to multiply two matrices. When I first learned the process of multiplying a matrix times a matrix, I asked myself, why would anyone ever want to multiply a matrix by a matrix? Because I was just thinking abstractly. I was just thinking numbers that had no headings and no meanings. And it made no sense to me at all. Until I saw an example like this, or like the soccer one, or something like that. And again, think about this. What happens if this guy had 17 different types of produce, 41 different gardens, and there were 13 different markets for him to go to? Can you see how huge that would get? To try to start crunching those numbers? That'd be a massive undertaking to try to do by hand, right? Okay, so what I want you to do for next time is just work on, you have quizzes 2.1, 2.2, and 2.3, and actually I haven't even looked to see how far you guys have been getting on that. But you should now be able to work on all three of those. We're going to spend one more day, Wednesday, tinkering with matrices, and then we're basically going to be done with matrices. I only want you to get just some basic matrix stuff. If you want to learn more about matrices, you should take Math 330, linear algebra and matrices. Okay? So you should be working on these quizzes, 1, 2, and 3. You should be working on your used car project. And then after this week, I'm going to give you another project to work on, a review day, and then we have a test that following Friday, October 4th. Any questions before we're out of here? You got 7 minutes left of class, so if you ask me any questions about any of your homework, quizzes, projects, go ahead. If not, I'll see you on Wednesday.